Hi, welcome to the fun probability problem solving sections. And today we're going to work on this problem here. This problem is that tell you x is a continuous random variable with PDF f of x equal to ax plus bx squared x from 0 to 1. So they give us a condition, the expected value of x equal to the 0.5 and find the variable x here. Okay, let's go ahead and go to our whiteboard and let's start to work on these problems here. Okay, so before we look at work on this problem, so let's first let's see here what the strategy we're going to use here. Okay, so for this problem here, the PDF, let's see here our PDF f of x is equal to the ax plus bx squared. Okay, and x is from 0 to 1, and we are looking for the variance of x. So the first things also the given. So we also the givens here. The information they given here is expected value of x is equal to the 0.5. Yeah. Okay, so when you try to do this problem here, the first thing you notice this PDF has two constants here. One is a and the other is b here. So we know the variance of x, the definition is pretty easy to use. And so the a and the b is here, but we have given conditions here, the expected value equal to the 0.5. So in order to find the a and the b, we know we need to have two equations to solve two variables, right? So the expected value will give us one equation. Now, what is the other equation we're going to use here to solve the AB? So we recognize for any PDF, if you add or integrate over its domains, what happens here? It will be 1, right? So even that condition is not given explicitly, but now we know that is the property of the PDF. So that is why I have the two variables and the two conditions here. So let's take a look here. So we know the 0 to 1, the f of x, so ax plus bx squared dx. We know this one has to be equal to 1. That's the very, very basic fundamental probabilities, right? When you integrate the PDF over the domain will be equal to 1. So this one is a simple integrations. So we will have, so this integrations here, we will have x to the square a over 2 plus b x cubed to the 3, right? Now we have 0 and 1 and equal to 1. So from here, you substitute, I can get a over 2 plus b over 3 equal to 1. So this is our first condition. Then I can use the condition it given to us is the expected value of x equal to 0.5. So I know the expected value of x, it will just be the x multiplied the PDFs here, right? So multiply the ax plus bx squared dx, then integrate over the domains here. So these ones here will give us, this is 0, 1, ax squared plus bx cubed, and then the dx is here. Okay, so this one is a pretty simple integration also. I can have this is a over 3 x to the cube plus 4. This is b x to the 4th 0, 1. And what is this one equal to? So this one equal to the 0.5, right? Now I will have a substitute. So it's a3 plus and the b over 4. So what is this one going to equal to here? So this one is equal to the 1/2. And so now I have two equations with two variables. So I solving the system of the equations, right? So I will be able to find the A and the B. So in here, I'm not going to do the algebra. So that after you solve this is a pretty simple two system of equations. So you will find that A equal to 6 and the B equal to -6. So here. Okay, after you get that, all right, so now I know by f of x is equal to what? The 6x minus 6x squared, correct? Okay, so this is a dx. So now I'm going to find the variance x. So this is after we find the a and the b here. Okay, so now the variance of x is equal to the expected value of x squared minus the expected value of x, the whole thing square. And we already know these things here is what? This one is given, right? So this is 0.5 to the square. So the only thing right now we need to find is the expected value of x squared. So it's the same thing. You take the x squared, then times the PDF. So right now I already know my PDF is 6x minus 6x squared dx 0 to 1. And then here, this will be 0 to 1. This is 6x cubed, right? Minus 6x the fourth dx here. All right. So then now in here, I can integrate. I can factor the 6 out, right? So in here, this will be x fourth over 4 minus x fifth over what? Fifth. Then I substitute 0 to 1. So here, right? So here, if you substitute, this will be the 6 1/4 minus 1/5, right? So this will give you the 6 over what? 20. So now I can substitute back to my variances here. So this will be 6 over 20. The expected value is what? Is 0.5, right? So 0.5 you squared, so it's 1 over 4, right? So it's 1 over 4, and then this will give us, so what is here? So this will give us 1 over 20. So that's what is our variance values here. So this problem is kind of pretty straightforward problem. So basically, you just need to recognize, in my PDF, I have two constants. So in order to solve it, you need to have two equations. So expected value give 1. So then the other one is use these properties, right? So I think this problem basically is to try to test you understand these properties, right? So that means that when you integrate the PDF over the domain, so it has to be equal to 1. All right, that's it. So it's pretty simple, but it's very nice problems here. Okay, so let's talk about the next problem in our next lecture videos here. Okay, bye-bye.